Light travels incredibly fast. How fast? Try 299,792 kilometers per second. That's fast enough to circle the Earth over 7 times in just 1 second. Imagine that speed. This mind-boggling speed is the fastest anything can travel in the universe. Nothing can go faster. Light's speed is constant too. Whether it's coming from the sun or a flashlight, it always travels at the same speed. This constant speed is crucial for understanding our universe. It's a fundamental constant in physics. Einstein's theory of relativity changed our understanding of space and time. One of its most important ideas? The speed of light is the ultimate speed limit in the universe. Nothing can travel faster. This speed limit isn't just a rule, it's woven into the fabric of space-time. As objects approach the speed of light, strange things happen. Time slows down. Distances shrink. This is not science fiction. These are real phenomena confirmed by experiments. The speed of light is a fundamental constant that governs the behavior of the universe. One of the strangest consequences of light's speed limit is time dilation. This phenomenon, predicted by Einstein's theory of relativity, suggests that time doesn't tick at the same rate for everyone. Instead, it can stretch or compress depending on how fast you're moving relative to the speed of light. Imagine 2 clocks, one on Earth and one on a spaceship, traveling at near the speed of light. The clock on Earth ticks away steadily, while the one on the spaceship ticks more slowly. This isn't just a theoretical idea, it's a real effect that has been observed and measured. Time would actually pass slower on the spaceship compared to Earth. If you were on that spaceship, you would age more slowly than your twin back on Earth. This means that astronauts traveling at high speeds could return home to find that more time has passed on Earth than they experienced. This isn't just a thought experiment. Scientists have conducted numerous experiments to test and confirm time dilation. By using highly precise atomic clocks, they have been able to measure the tiny differences in time experienced by objects moving at different speeds. Time dilation has been experimentally verified using atomic clocks. These clocks are so accurate that they can detect even the smallest changes in the passage of time. When one clock is flown around the world on a jet, it shows a slight difference in time compared to a clock that stayed on the ground. The faster an object moves, the slower time passes for it relative to a stationary observer. This effect becomes more pronounced as the object's speed approaches the speed of light. For everyday speeds, like those of cars or planes, the difference is minuscule, but it becomes significant at higher velocities. This mind-bending concept is a direct result of the speed of light being constant for all observers. No matter how fast you're moving, light always travels at the same speed. This constancy leads to the strange and fascinating effects of time dilation. It's a testament to the profound implications of Einstein's theories. His insights into the nature of space and time have revolutionized our understanding of the universe, showing us that time is not an absolute, but a flexible dimension that can be stretched and compressed by the forces of nature. Light isn't just a scientific curiosity, it's essential for life itself. Plants use sunlight for photosynthesis, converting light energy into chemical energy to fuel their growth. Without light, there would be no plants, and without plants, there would be no us. Light also plays a crucial role in our modern world. Fiber optic cables, which transmit data as pulses of light, power the internet. We rely on artificial light to illuminate our homes and cities. Light is everywhere, shaping our lives in countless ways. Section 5. Light from distant stars. When we look up at the stars, we are seeing light that has traveled vast distances across the cosmos. Some of this light has been traveling for millions or even billions of years to reach us. By studying this ancient light, astronomers can learn about the history of the universe. The light from these distant stars tells a story. It reveals the composition of stars, the formation of galaxies, and the expansion of the universe itself. Light is our window into the vast cosmic expanse. Section 6. Light's role in space travel. Light is not only essential for understanding the universe, but also for exploring it. From the earliest days of astronomy, light has been our primary tool for peering into the cosmos. Telescopes, both on Earth and in space, capture light from distant stars and galaxies, allowing us to study their properties and understand the universe's vastness. Spacecraft rely on radio waves, a form of light, to communicate with Earth. These radio waves are crucial for sending data back and forth, whether it's information from a Mars rover or signals from a distant space probe. These signals travel at the speed of light, which is approximately 299,792 kilometers per second, or about 186,282 miles per second. But even then, it takes time for them to reach their destination. For instance, it takes about 8 minutes for light from the Sun to reach Earth, and several hours for signals from the outer planets to get back to us. The vast distances in space pose significant challenges for space exploration. As we venture further into the cosmos, the time delay in communication becomes more pronounced, making real-time control of distant spacecraft increasingly difficult. The speed of light, while incredibly fast, is still finite. This limitation means that our current methods of space travel and communication are bound by this universal speed limit. This means that future missions to other star systems which are light years away will face even greater challenges. The nearest star system, Alpha Centauri, is over 4 light years away, meaning it would take over 4 years for light to travel from there to here. To overcome these vast distances, we will require innovative propulsion systems. Concepts like warp drives, which theoretically could allow faster-than-light travel, are being explored, but they remain in the realm of science fiction for now. A deep understanding of the limits imposed by the speed of light is essential for planning future space missions. As we push the boundaries of our knowledge and technology, light will continue to play a pivotal role in our quest to explore the universe. Section 7. The future of light technology. Scientists are constantly finding new ways to harness the power of light. Lasers, highly focused beams of light, are used in everything from barcode scanners to eye surgery. Fiber optic communication networks are becoming faster and more efficient. In the future, light-based technologies hold immense promise for fields like computing, communication, and medicine. Researchers are exploring the potential of quantum computing, which would use the properties of light to perform calculations at speeds unimaginable today. Section 8. Light in medicine. Light is playing an increasingly important role in medicine. Medical imaging techniques like X-rays and MRI scans use different forms of light to peer inside the human body without invasive procedures. Laser surgery allows doctors to perform delicate operations with incredible precision. As our understanding of light and its interaction with biological tissues grows, we can expect even more innovative medical applications. Light-based therapies hold promise for treating a wide range of diseases from cancer to Alzheimer's. Section 9. Light's fundamental importance. The speed of light is more than just a number. It's a fundamental constant that governs the behavior of the universe. It shapes our understanding of space, time, and the very nature of reality. From the smallest atom to the largest galaxy, light plays a vital role in the cosmic dance. It's the messenger that carries information across vast distances, the energy source that powers life, and the key to unlocking the secrets of the universe. Section 10. A universe bathed in light. We live in a universe bathed in light. This light, which travels across the vast expanses of space, reaches us from countless sources, each telling a story of its own. From the warm glow of the sun, which sustains life on our planet and provides the energy needed for growth and survival, to the twinkling of distant stars, light illuminates our world in ways both seen and unseen. These distant stars, many of which are light years away, offer a glimpse into the past, as their light takes years, even centuries, to reach us. This light connects us to the cosmos, creating a bridge between our world and the vast universe beyond. It serves as a reminder of our place in the grand scheme of things, a small yet significant part of a much larger whole. Understanding the speed of light, which is approximately 299,792 kilometers per second, is essential for comprehending the vastness of space, the nature of time, and the distances that separate celestial bodies. This speed, though incredibly fast, still means that light from the nearest star takes over 4 years to reach us. The intricate workings of the universe itself are illuminated by this light, revealing the beauty and complexity of galaxies, nebulae, and other celestial phenomena. Each photon of light carries information about its source, allowing scientists to study and understand the universe in greater detail. As we continue to explore the cosmos, sending spacecraft to distant galaxies and peering through powerful telescopes and delve deeper into the mysteries of the universe, we rely on light to guide our way. Scientists in observatories around the world analyze light from distant stars and galaxies, uncovering secrets that have been hidden for eons. The speed of light will remain a constant guidepost, a fundamental constant of nature that helps us navigate the vastness of space. It is a beacon that illuminates the path to new discoveries, and a deeper appreciation for the wonders of the cosmos. As we decode the messages carried by light, we gain insights into the origins, evolution, and future of the universe. This journey of exploration and discovery guided by light enriches our understanding and fuels our curiosity, driving us to seek out the unknown and marvel at the beauty of the cosmos.